So welcome back to A2 for Mathematics. In this video we'll be talking about logarithm and exponential, and first we'll be talking about the logarithms and some bit properties. Let's just say we have a function. So this function, different from other function, is that it is an exponential function, which is that y is equal to a to the power of x. So a here is a constant. So this constant can be, say, 1, 2, 3, or any numbers, and x is another variables, y. So this function is y equal to a to the power of x. Now this kind of function, where you have a constant to the power of a variable, this function is described as exponential. So these functions are called exponential function. Now we have y is equal to a to the power of x. So the logarithm came in when we have say log. So in this case, since y is equal to a to the power of x, then you have log to the base of a. Y is actually equal to x. Right, so remember that log is to find the power in a function. So let's say a to the power of x equal to y. So that means log of a, log of that constant of y will get you x. So log a, log to the base a of y is equal to x. So I suggest you should pause the video and sort of understand this idea that logs to the base of a of y is equal to x. This is a very important concept that you need to get familiarized. So this means a to the power of x is equal to y. Right. Now let's talk about some of the property of logarithms. So the logarithm say, so let's say you have log of a number m and log of n. Now when we write log without a base, that means this is base 10. So that means this is 10. So if 10 to the power of x is equal to m, then log of m is equal to x. So we don't have to write the base of 10 here. So in this case, we will use log of a. This is any base. So these are the properties of a logarithm. So first we have the multiplication properties. Multiplication. So that states that if log to the base a of m plus n, m times n, be equal to log to base a of m plus log base a of n. Now why is that? So just say m is equal to a to the power of x and n is equal to a to the power of y. So m times n would be a to the power of x times a to the power of y. Now this is equal to a to the power of x plus y. And so that log a m times n is equal to x plus y, which is equal to log a log of base a m plus log of base a n. So this, so x is here, y is here, and x plus y is here. That is the reason for this formula. Right. Multiplication. Now let's get to division. So similarly, we have log of a m over n. So this is equal to the log of a of m minus the log of a of n. The reason is similar to this one. So we have m over n is equal to a to the power of x over a to the power of y. Now this is a to the power of x minus y. So x minus y is for this one. X is this one minus y is this one. So that is the basic origin of these two formula. So a few others logarithm rules. So we have a to the power of 0 is always equal to 1. So the log of a of any a, so this is any numbers a, so log of a of 1 is always equal to 0. That's another rule. So what about power? So we have talked about multiplication, division, and logarithm of 1. So now let's talk about the logarithm of power. So say we want to find the log of a of m to the power of n. Now this is equal to n times log a to m. So n goes here, and this is log of a of m. So why is that? So we remember in the multiplication is if you have log a of m times m times m, say this is n times. So using the multiplication rules, we have this is equal to log of a of m plus log of a, the base of a of m, plus etc. So here we have n times of this, which is eventually equal to this. So that is the origin of this formula. So that is the power of a logarithm. So now we have reciprocals. So now we have the log a of 1 over m. So this so we have known that m is equal to a to the power of x, right? So 1 over m is equal to a to the power of minus x. So that's what we have known. So if it's equal to a to the power of minus x, so this is actually equal to log to the base of a of m, and the negative values of log a to the base of m. So this is x, this part is x, and this minus part is this one. So that's the origin for this formula. So log to the base of a 1 over m is equal to minus log to the base of a of m. So now let's talk about roots. So let's find the log of the n roots of x, to the base of a of n roots of x. So we have this is equal to the log of a of x to the power of 1 over n. Right, so this is to the power of x to the power of 1 over n. So this n roots of x is equal to this. Now from the power rule, you have known that 1 over n. So this is equal to 1 over n times log a of x. This is another formula that we've got. Now the last formula is simply the log of a to the power of a. So in this case, x is equal to a. So it's obvious that a to the power of 1 is equal to a. So this is always equal to 1. Now these formula, I will list them all again. So these are the summaries of all the rules. So first we have the multiplication rules, we have the division rule, we have the log of 1 rule, we have the power rule, we have the reciprocal rule, we have the roots rule, and we have the log to with base rule. So for now, this might be quite confusing, but once you actually try doing some of the question, you start to get familiarized with this concept, and when it's the exam, you can if you can use these quite you can use these. So in the exam, if you can use these professionally, you can actually work very well through your exam, really.